All right, so one of the things I did not show you with Chemsketch was how to do some of the big molecules. When you're doing the big molecules, you do not want to do it by scratch. Scratch means like this. So let's say I was doing glucose. I would not do this. Carbon, carbon, hexagon, right? Carbon, 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 carbon. And then I need an oxygen here. Hydroxyl group down, down, up, down, another CH group here with an OH group here. So I won't do that because first of all, that's not accurate, so I'd have to clean it. And when I clean this, hit F9 on my keyboard, clean structure, I end up getting this. And this is not what glucose looks like. So this would be a very poor two-dimensional structure. If you put this in a 3D mode, see last 3D viewer, you will get something reasonable, but still, there is a better way to do this. Go back to Chemsketch, select the molecule, copy to 3D, take a look at it. Right. So if I take a look at this molecule here, it's very flat. I got all these hydroxyl groups that are sticking out on the outside. This is wrong. Okay, so we're not going to do this. So we'll go back to Chemsketch. So what you should do for these big molecules is you go into templates and you go to the template window. In the template window, you're going to have some things on here by default. But if what you're looking for is not here, then you can go to this drop-down box and select from any of these. And each of these have many pages. So you'll notice that there's sugars, alpha D furanose rings, and sugars alpha D pyranose rings, and then beta furanose and pyranose. Furanose and pyranose doesn't mean anything to you. It's a type of projection. I already have them in my template window here, so I'm going to select the furanose. Let's look at the pyranose and see what they look like. So here's a pyranose, here's a furanose. So if you look at these two, you'll see that the furanose looks more similar to the ones I've been drawing. So alpha D pyranose. So these all have the first part of it, the prefix, represents the sugar that you're familiar with. So here, this is galactose. This is glucose. Right. Mannose. So I want glucose here. So I'm going to grab glucose by clicking on the molecule, and I'm going to click on the screen. So now I've got glucose. That's it. Right. So now that glucose, this I could put into my Word document. So if I have a Word document available, and copy this, edit copy, and go to my Word document, paste it in, and I put it in a table to answer the questions that are appropriate, and there's glucose. Glucose is done. If you need to 3D mode this, then you can 3D optimize. I forgot that step on the last one. I should have 3D optimized it. I was just trying to get to this place here, but I 3D optimize it. Remove hydrogens before. I don't want to. I want my hydrogens to be there. It contains stereo bonds. You want to replace them with single bonds? Sure, it doesn't actually matter. And then I can copy that to 3D. And then I can rotate it in 3D and take a look at all the different structures or whatever. But this is the balls and sticks model. And you'll see that my hydroxyl groups are above and below the ring as they're supposed to be. Okay. Now suppose you want to do maltose, disaccharide. So if you want to do maltose, you're going to do it from before you 3D optimize it. Whenever you're doing the copy and paste into Word, you want to do the 3D optimize after and only when you're ready to go to 3D mode. I'm going to go back to templates, my template window, alpha D pyranose. I'm going to grab glucose once, and it's still there twice. Now I want to join these two together. And as you recall, it's an alpha linkage right here. I'm going to grab this hydroxyl group, and I'm going to put it on top of this hydroxyl group, and it's going to bond them. So the water's gone, and now I just have this oxygen bridge. So this is maltose. So now I can copy that and paste it into my Word document. And there's my maltose. And then I can select it again. And I can 3D optimize it. I don't want to remove my hydrogens. I sure replace my stereo bonds. It doesn't matter. I haven't explained what those bonds are, so it's not important. And then I can copy and paste that, copy that over to my 3D mode. And then I can have my balls and sticks model, which I can then incorporate into my Word document. Okay. So that's how I can get this disaccharide. I can get into polysaccharides now. I can add a whole bunch of glucose units together. I can also go to my amino acids, right? So if my amino acids, if I ask you to do a dipeptide, I can grab alanine, put it in here, and I can grab leucine, I guess. Now you have to recognize where the actual amino group is, right? So here's the carboxylic acid group, here's the alpha carbon, and here's the base. So this part here, right here, that's the R group. Over here, I have the carboxylic acid, the alpha group, alpha carbon, and the base. So all this here is the residue. So if I'm actually going to react these two, recall that the peptide bond happens between the hydrogen of the base and the OH of the carboxylic acid group. So I'd have to rotate this. Up here in the menu bar, there's a rotation selection tool. Just like that, it allows me to rotate these. If I get my arrow in the right spot here, so I can rotate it around as necessary. Okay, so this is my carboxylic acid group. There's my OH here. And I'm going to grab this and rotate it. And then I can form a bond between my NH2 over here and my OH, and I have that peptide bond. So if you're doing the big macromolecules, take a look at the template window, see what's available. There's quite a few things here, and you'll see most of them if you go down this drop down. Most of what you're going to be doing is going to be the carbohydrates and the amino acids. When you get to the big hydrocarbons, you're just going to have to draw them, but they're pretty easy to do. You just draw a long hydrocarbon with 18 pieces and then 18 carbons and add the carboxylic acid group at the end, and it's pretty straightforward. Remember when you do your Chemsketch that you must include your Chemsketch file. I'm not marking your Chemsketch file, but you must include it. And I'll look at it as if it were like, you know, the draft work of your English essay. It's the same idea. When you are making molecules, you have this option of adding pages. So see this pages menu? Click on this, new page. So down here it says page 2 of 2. I can go back to page 1. It's page 2. So that's how I can quickly switch between pages. And so you can have many pages. You can put one page per question or one page per molecule, and that will allow you to copy 3D easily, and then it will allow me to see that you've done the work and that you understand what the models look like and all that sort of stuff. So hopefully that answers your questions about doing big molecules. I don't think there's anything else with Chemsketch you need to know, but if there is, send me an email and I'll make up another video.